Hello everyone, welcome to this channel Fly with Physics and myself Adira. So we are continuing with our chapter Electric Charges and Field, and today we are going to study a really important topic in this chapter. It is Coulombs Law. This is a really important topic and I'll give you a guarantee that there will be at least one question from this topic in your board exam. That's for sure, and I have seen questions from this topic in NEET and JEE exams in some year. So you can't skip this topic, it is really important. So without further talking, let's get started. Coulombs law. So before getting into the definition of what is Coulombs law, let's consider two charges, Q1 and Q2. And these two charges are kept in a distance of r. Okay. So Coulomb's law states that force between two charges are directly proportional to the product of the magnitude of two charges and inversely proportional to the square of the distance between them. That means the force that is exerted by two charges is directly proportional to the product of the magnitude of the two charges. Product of the magnitude means Q1, Q2, and inversely proportional to the square of the distance between them. Here distance between Q1 and Q2 is r, so by r square. F is proportional to Q1, Q2 by r square, where Q1, Q2 are point charges. So here you can see it is a proportionality sign. So for taking away this proportionality and putting equal to, we need to give a proportionality constant. So F is equal to K Q1 Q2 by R square, where K is a proportionality constant. And the value of K was found out as 9 into 10 raised to 9 Newton meter square Coulomb inverse square. So this is really important value and you should by heart this. The value of K is equal to 9 into 10 raised to 9. And unit is Newton meter square Coulomb inverse square, and you may have to apply this in the problems directly, so you should by heart this. Now let's look into the history of Coulomb's law. It was Charles Auguste de Coulomb who proposed the Coulomb's law, and he proposed this by doing following experiment. He supposed a metallic sphere of charge Q, and he brought an uncharged sphere and kept the uncharged metallic sphere in contact with the first metallic sphere. So what happens? The charges get spread in both metallic sphere, and by symmetry each metallic sphere contains Q by 2 charges. Likewise, he continued this experiment by keeping many more metallic sphere in contact. What he done is that he just separated these metallic spheres and he kept them in different distance of r. And the main thing you should notice here that each metallic sphere was considered as a point charges. So for considering this metallic sphere as a point charge, the value of r must be greater than the radius of the sphere. So if the r is much greater than the radius of the sphere, each sphere can be considered as a point charges. So this was the experiment by which Charles Auguste de Coulomb proposed Coulomb's law. So in the last slide we have talked about the value of K is equal to 9 into 10 raised to 9 Newton meter square Coulomb inverse square, and this value of K can be also written as 1 by 4 pi epsilon 0, which has the same value as 9 into 10 raised to 9 Newton meter square Coulomb inverse square. And this epsilon 0 is permittivity of free space. So what is free space? Free space is the place which is vacuum, and the value of epsilon 0 is 8.853 into 10 raised to minus 12 Coulomb square Newton inverse meter square inverse. Now, so by combining all this, you can write the formula for force as F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. This is a really important formula. This is the mathematical representation for Coulomb's law, and you can expect at least one question from this formula. So F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square, where Q1 Q2 are the magnitude of the charges and R is the distance between the charges. Now let's look into what is a permittivity. It is the property of the medium which determines the electric force between two charges situated in that medium. So here we have considered that this 2 Q1 and Q2 is situated in free space. So this Q1 and Q2 are kept in free space. So we took the epsilon 0, the permittivity of free space. Now let's look what is the force between the charges if the charges are kept in a medium. So now it's not kept in a free space, vacuum, it is kept in a medium. You can consider air as a medium, water, dielectric, any medium. So Q1 and Q2 are our charges and R is the distance between them. So consider the force of the charges in the medium as Fm. So Fm is equal to 1 by 4 pi epsilon Q1 Q2 by R square. Here we use epsilon. So what is epsilon? Epsilon is the permittivity of the medium. In the last slide you have seen here we used epsilon naught, that is permittivity of free space. Here we use epsilon, which is the permittivity of the medium. Now let's take the ratio of the force in the free space and also the force in the medium. Taking the ratio F by Fm. F is the force of the charges when it is kept in the free space and Fm is the force of the charges when it is kept in a medium. So F by Fm is equal to, let's divide this. So 1 by 4 pi epsilon 0 Q1 Q2 by R square whole divided by 1 by 4 pi epsilon Q1 Q2 by R square. So what happens? This whole term cuts and go. Okay. And this 1 by 4 pi and this 1 by 4 pi cuts and go. Now what remains? F by Fm, that means force on the free space divided by force on the medium when the charges are kept in the medium is equal to epsilon by epsilon naught. These two, only these epsilon 0 and epsilon remains and this epsilon goes to the top. The final answer we get it as epsilon by epsilon 0. This epsilon by epsilon 0 is called as epsilon R, which is called as relative permittivity. So now you know how to find the force between charges if they are kept in the medium. Now let's look into the limitations of Coulomb's law. The law is applicable only for point charges at rest. Coulomb's law can be only applied in those cases where the inverse square law is obeyed. So what is the inverse square law? This is the formula to find the force using Coulomb's law. So here you can see force is inversely proportional to the square of the distance between them. So these types of laws are called inverse square law. And you have already studied an example for inverse square law, which is gravitational law. F is equal to g m1 m2 by r square, right? And g is the gravitational constant, m1 m2 are the masses of the two objects and r is the distance between them. So in this equation also F is inversely proportional to the r square. So this is also an example for inverse square law. And you could see a similarity between these two force laws. These two equations are example for inverse square law. It is difficult to implement Coulomb's law where charges are in arbitrary shape because in such cases we cannot determine the distance between the charges. Arbitrary shape means a just random shape. So these are the limitations for Coulomb's law. So now let's do a question. So the question is, what is the ratio of repulsive Coulomb force and attractive gravitational force between two protons? And options are given. So pause the video, try this question yourself, look if you are getting the answer, and after that check if it is correct or not. And if you are not getting how to solve this, don't worry, I will tell you. So if you are not getting, we can solve it together, okay? So the question is, what is the ratio of repulsive Coulomb force and attractive gravitational force between two protons? So they have given us two protons and we need to find the ratio of Coulomb's force and gravitational force. So we know that according to Coulomb's law, the equation to find force between two charges is F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square, right? And the gravitational force, equation for gravitational force, we can denote it by Fg, okay? Fg is equal to G m1 m2 by R square, where G is the gravitational constant, m1 m2 are the masses of two body. Here we have two protons and R is the distance between them. Now first let's find the Coulomb's force. So F, you know the value of 1 by 4 pi epsilon 0. It is 9 into 10 raised to 9. And Q1, Q2. So what is the value of charge of 2 protons? Q1 is equal to Q2. What is the charge of the proton? Plus E, right? Value of E is 1.6 into 10 raised to minus 19 Coulomb. Now let's apply this value in this equation. So by multiplying this two value, we will get it as 2.304 into 10 raised to minus 28 by. Now we have found the Coulomb's force value. Now let's look into the gravitational force. So what is the value for G? G is the gravitational constant and G is equal to 6.67 into 10 raised to minus 11. Now let's look into the mass of the proton. What is the value for the mass of the proton? M1 is equal to M2 is equal to, what is the mass of proton? It is 1.67 into 10 raised to minus 27. So this is the mass of the proton. Now let's apply this to value in this equation. We will get it that. So by applying the value, we get that 6.67 into 10 raised to minus 11 into 1.67 into 10 raised to minus 27 all square by r square. So by multiplying this, we will get Fg is equal to 1.84 into 10 raised to minus 6. So now we have got both the value. I hope you understand this. Now what is the question? We should find the ratio of this, right? Simple, just put the value, just divide it. You will get F by Fg, and by dividing this 2, you will get the final value as 1.24 into 10 raised to 36. So now let's look how we can represent force in a vector form. As you all know, force is a vector because it has both magnitude and direction. The quantity which has both direction and magnitude is known as vector quantity. So force has both direction and magnitude, so it is a vector quantity. Now let's look into this diagram. Let us consider 2 point charges Q1 and Q2 and they are unit positive charges. So since they are same charges, means these two are positive charges, what happens? These two charges repels. So the direction of force is outward. See? If let's consider that there are two charges, this is a positive charge and this is a negative charge. So now what will be the direction of force? So the direction of force will be inward. Always, unlike charges attract. So since they are attractive force, the direction of forces will be in this direction. Okay. The force on Q1 due to Q2 is denoted by F12 and force on Q2 due to Q1 is denoted by F21. And vector R1 and vector R2 are the position vectors of the charges Q1 and Q2 from the origin. So what are position vectors? Position vector is used to specify the position of a certain body. In general, position vector of an object is measured from the origin. So now let's look into this diagram once more. So this is our origin and vector R1 is our position vector to Q1 and our vector R2 is the position vector to our charge Q2, and this distance between the charges are vector R21, which is equal to vector R2 minus vector R1. So this is the diagram. From this we are going to write the force in the vector form. So force F21 is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R21 square, where F21 is the force on Q1 due to Q2. And what is this R21 cap? It is a unit vector which denotes the direction of force, and this unit vector can be written as R21 cap is equal to vector R21 divided by magnitude of this vector, that means modulus of R21, where modulus of R21 is the magnitude. Let me give you an example. Let's consider a vector R is equal to 3i plus 4j. So this is our vector. So how can we find the modulus? Modulus of R21, which is magnitude of vector, is equal to R21 is equal to root of 3 square, You don't want to take I and j, only the magnitude. 3 square plus 4 square, that is equal to 9 plus 16, that is root of 25, that is equal to 5. So this is how you will find magnitude of the vector quantity. Now can you tell me what will be the R21 cap? R21 cap is equal to 3i plus 4j by 5. So this is how you will find the unit vector. Now let's look into F12. So what is F12? It is a force on Q2 due to Q1. So F12 is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R12 square, where F12 is the force on Q2 due to Q1 and R12 cap is equal to vector R12 by modulus of R12. So this is how you represent the force due to two charges in a vector form. Okay. Now let's look into the principle of superposition. Here you could tell that force due to multiple charges. So let's look into this diagram first of all. There are three charges, Q1, Q2 and Q3, and R2 is the position vector from the origin to Q2 and R3 is the position vector from origin to Q3, and R1 vector is the position vector from origin to the charge Q1. Now you could tell that this Q1 experience a force from Q2 and also a force from Q3. So the force on Q1 due to Q3 is F13 and the force on Q1 due to Q2 is F12 and the direction is given here. Now the question is, what is the total force experienced by this charge Q1? So this is given by our principle of superposition. Principle of superposition states that force on any charge due to number of other charges. Due to number of other charges means here we have Q2 and Q3 and force is exerted on Q1 is the vector sum of all the forces on that charge. Vector sum of all the forces on that charge. So all the forces means F13 and F12 due to other charges due to Q1 and Q3. So let's read it once more. Principle of superposition states that force on any charge due to number of other charges is the vector sum of all the forces on that charge due to other charges. So this is the statement for principle of superposition. Now let's look how can we represent it in a mathematical form. Force on Q1 due to Q2, that is F12 is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R12 square, and force on Q1 due to Q3 is F13 is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R13 square. Now the resultant force, that is total force, according to the principle of superposition, the total force will be the vector sum of all the forces acting upon that charge. Okay. So Ft is equal to F12 plus F13. That is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R12 square plus 1 by 4 pi epsilon 0 Q1 Q2 by R13 square. So this will be the total force experienced by our charge Q1. Now if there are n number of charges, now we have considered an example of 3 number of charges. Now what happens if there are n number of charges in a system? Then the resultant force on each charge can be found out by this equation Ft, that means resultant force is equal to, force total is equal to Q1 4 pi epsilon 0. Here we are going to find the resultant force experienced by Q1. So Q1 into 1 by 4 pi epsilon 0 into summation of I equal to 2 to n Qi by R1i square and R1i cap. So this is the equation to find the resultant force if there are n number of charges in a system. So now let's do a question related to superposition principle, and this question was asked in IIT exam in 1995. So let's do it. An infinite number of charges each equal to 4 microcoulomb was placed along x-axis at x equal to 1, x equal to 2 meter, x equal to 4 meter, x equal to 8 meter and so on. Find the total force on a charge in 1 coulomb placed at the origin. So now let's study the question first. An infinite number of charges equal to 4 microcoulomb. So there are many charges that has the value of 4 microcoulomb, and these charges are placed along x-axis at different points like 1 meter, 2 meter, 3 meter, 8 meter, and it is continuing since it's an infinite number. And we should find the total force on a charge of 1 coulomb placed at the origin. So the equation for superposition is F is equal to 1 by 4 pi epsilon 0 Q1 summation of I is equal to 2 to n Qi by R1 I square. Right? What is the value of Qi? It is given in the question. What is it? Q1 is equal to 1 coulomb. And what is the value for all the charges present in the system has the same value. So you could write it as Q2 is equal to Q3 is equal to like this up to Qn. Qn is equal to 4 microcoulomb, that is 4 into 10 raised to micro means 10 raised to minus 6 coulomb. Now let's put this value in the equation. F is equal to 1 by 4 pi epsilon 0, value of 1 by 4 pi epsilon 0 is 9 into 10 raised to 9, and value of Q1 it is 1. We can take Qi out of the summation since it is a constant value. We could take it out and write it as 4 into 10 raised to minus 6. So now we get this equation, and if you just look at this part of the equation, you could find it as a geometrical propagation series. So equation for JP, geometrical propagation, is A by 1 minus R, right? Where A is the first term and R is the common ratio. So here A is equal to 1, and what is R? R is equal to common ratio 1 by 4. Now let's apply this A and R in this equation and find out the value for JP series. So we will get the answer for as 4 by 3. So this part we will get it as 4. This part we will get it as 4 by 3. So let's calculate now. F is equal to, put all the values and find the answer. By solving this, you will get the answer as 4.8 into 10 raised to 4 Newton. So this is the answer for the force experienced by the charge Q1 due to this infinite number of charges. So this is how we will do a question from superposition principle. So this is really important question. Try it yourself once more, and don't worry about the notes. You can find the notes Telegram channel, and if you haven't joined in the channel, I have provided the link in the description box, so check it out. And also this week's assignment will be provided to you in the Telegram channel. Thank you for watching the video. If you like this video, press on the like button, and if you find this video as useful, please share it with your friends so I can help them also, and subscribe to the channel and press on the bell icon so you will get the notification whenever I upload a new video. So see you in the next class. Till then, bye.